Good afternoon everyone. Now I am going to explain you about the numericals of the chapter solution and the colligative property. So I have given the sums and the homework, that is the assignment, in the PDF. So you please first go through it, then you watch the video. So in the first sum, I have asked you to calculate the mass of a non-volatile solute having the molar mass 180 gram per mole, which should be dissolved in 450 gram of water to reduce its vapor pressure to the value of 17.44 mm of mercury. And here the data given is that the vapor pressure of pure water at 293 Kelvin is 17.535 mm of mercury. So this is the first sum which is related to the first colligative property, that is the relative lowering of vapor pressure. And in this sum, you please see the question. Before doing the sum, you see the question, read out the question twice or thrice, isn't it? So here what is asked? The mass of the solute. So WB you have to find out, and here that WB value you have to find out so that the volume, the vapor pressure of the solution will be reduced. Now here I am writing the given data. So here first given data is that the vapor pressure of pure solvent, that is nothing but water, and what is the value given at 293? P naught A is equal to 17.535 mm of mercury. And here when you dissolve the solute, that solute, that time that vapor pressure of the solution will be lowered down, and that vapor pressure is taken to be as a PS or PA, which is equal to 17.44. it is given in the question itself. And here the mass of the solvent is given as 450 gram, and molar mass of the solute is 180 gram per mole. And here since water is the solvent, so what is the molar mass of water? 18 gram per mole. So it is known to you. So WB we have to find out, and we have to use the formula P naught A minus PA. Instead of PA you can write down PS also, because the values are same, divided by P naught A equals to what? The formula is what? WB into MA divided by WA into MB, where WB you have to calculate, MA is the mass of the molar mass of the solvent, MB is the molar mass of the solute, and WA is the given mass of the solvent, isn't it? So I have put all the value which is given to you, and in the right hand side I have put the what are the values given to you. And if you will solve it stepwise, so you will get the value of WB to be as a what? 24.38 gram. So this is the first sum that which I have given you, and the second sum whatever I have given, that is in the form of homework, and in the notes I have given all the hints, so you please try it. Now coming to the third sum. So third sum is related to the second colligative property, that is elevation in boiling point. And in the sum you see, the read out the sum first. 18 gram of glucose, that is having the formula what? C6H12O6, and the molar mass 180 gram per mole, is dissolved in 1 kg of water. Water is the solvent here, and here glucose is the solute, in a saucepan. At what temperature will this solution boil? So you have to find out the boiling point of the solution, that is TB, capital T suffix small b. And given data are what? That Kb value, that is the molar elevation constant for water, is given as 0.52 Kelvin kg per mole, and boiling point of pure water is known to you, but here I have given it as what? 373.15 Kelvin. Now in this sum what you have to find out? That is TB, that is the boiling point of the solution. So directly we will not find out. First we will calculate what is the elevation in boiling point, that is delta TB. So delta TB, once we calculate, we can find out easily what is the value of what? TB, because as we got that delta TB is equal to what? TB minus T naught B. So T naught B is given, delta TB we will calculate, and TB we can easily calculate, isn't it? Now come to the given data. Now for first data is what? That given mass of the solute, which is what is it is for the glucose, it is given as 18 gram, and here mass of the solvent, which is given as 1 kg, and here Kb value, as I told you, it is given to you, and molar mass of glucose is given as 180 gram per mole. If it is not given, from the molecular formula you can calculate by adding all the atomic masses of all the atoms present in glucose. And here T naught B, that is the boiling point of pure solvent, that is the water, is 373.15 Kelvin, and Tb you have to calculate. So since we know delta Tb equals to what? Kb into m. So writing the formula is a very important. As you know, in CBSE the marks is given in stepwise. Like this sum, here also writing the formula and showing the steps is it will give you marks. If you will skip, your marks will be reduced. So I have written here the formula delta Tb equals to Kb into m, where we have substituted a value of m by using Wb divided by Wa into Mb. Here I have not used 1000 because Wa, that is the mass of the solvent, is already given in kg. So no need to use 1000 here. So I have put all the data given, and by solving it we got the value of delta Tb as what? 0.052 Kelvin. So we got the value of delta Tb, so it is very easy to calculate the value of Tb. And as I told you earlier, delta Tb equals to what? Tb minus T naught B. This implies what? Tb equals to what? Delta Tb plus T naught B, and this value we have calculated just now. This value is given to you, and we can easily find out what is the boiling point of the solution. And you see the boiling point of the solution, what we got, it is 373.202 Kelvin. I repeat, 373.202 Kelvin. This is for the solution, and this is for the pure solvent. So you have seen here it is 373.15, and it may be point wise, but the boiling point of the solution is always greater than that of the pure solvent. That's why we have termed this property as a what? Elevation in boiling point. And if your calculation is correct, so you will observe always this boiling point, that is the boiling point of the solution, will be greater than that of the pure solvent. Is it clear? So again I am giving you that the fourth sum as a homework, and I have given you all the hints. Now I will proceed to the sum related to the next colligative property, that is the depression in freezing point.